Everyone, my name is Saurabh Singh, and today I'm going to teach about the compaction test of soil. And this is from unit number 5th, and this is lecture number 25. After watching this video, if you have any doubt, you can contact to me, and you can also write email on saurabh.singh@myyanbihar.com. So come on the learning objective and learning outcome. Here you will know about the compaction test of soil, and you will also know what is the different method of and different application of a deep and shallow foundation. In learning outcome, you will able to learn about the compaction test of soil. First, we will see the standard Proctor test. After that, we will see the standard modified Proctor test. As is mentioned here, soil is compacted into mold in 5 equal layers, each layer receiving 25 blows of hammer of standard weight. The energy supplied in the test is 595 joule per meter cube. The important dimensions are here. These the dimensions are very important, and this dimension may be asked in your exam. What is the volume of mold? If anybody will ask you what is the volume of mold, you can answer it. It is 1000 centimeter cube. And what is the mass of hammer, which is given here 2.5 kg, and drop of hammer will be from the 300 mm height. Now you can see this is the equipment which is used in the standard Proctor test. This is your mold and this is your hammer, and this is also your mold where you have to put our soil in 3 layer and 5 layer. Now we will see the which factor affect the compaction. First, you can see water content of the soil. Second is given amount of compaction, type of soil being compacted, the amount of competitive energy used, the method of compaction, thickness of layer, saturation line, admixture, and stone content. These are the factors which affect the compaction. If suppose water content will be if water content in soil will be high, then your soil will be not compacted very well. Amount of compaction, this is also very important. If you will compact your soil more, means your soil will be fully compacted. And types of soil, so this is also very important uh, type, which is this is also very important factor which affect on the compaction, because soil type is also like, if suppose there is alluvial soil, it can be compacted very well, but if there will be a sandy soil, it can be not compacted very well, just because of some properties of the soil. So how water content below OMC can affect the compaction, you can see here in this graph. As the water content increase, the particle develop larger and larger water film around them, which tend lubricate the particle and make them easier to move about the reoriented into the denser configuration. As you can see on the graph, there is dry unit weight, that is your water content, which is represented by WC. And water content at OMC, what will be the water content at OMC? Optimum moisture content, you can see here. The density is at the maximum, and it does not increase any further. So you can see here, that is your graph, and this is the showing relation between the dry unit weight of a soil and water content of a soil. And water content above 1C, what will affect? As you can see, water start to replace soil particle in the mold, and dry unit weight start to decrease. As you can see here, if water content will be increased, then dry unit weight will be also decrease. Okay, at one point, only at one point, you will get your maximum dry density, as you can see here, and it will be denoted as the OMC, which is known as optimum moisture content. These things you need to understand. What is the OMC? We can only get the maximum dry density on the optimum moisture content, which you have to determine in the lab. And it may be different for the sand, it may be different for the silt, and it will be also different for the gravel. Now we will see how soil type can affect the compaction. This is also very important factor. Soil type, grain size. shape of the soil grain, amount and type of the clay mineral present in the specific gravity of soil solids have a great influence on the dry unit weight and optimum moisture content. Uniformly graded sand or poorly graded sand in nature difficult to compact them. Now we will see the what is the definition and what is the correct definition of a compaction. Compaction increase the strength and characteristics of soil, which is increase the bearing capacity of foundation construction over them. So you can understand here, by the compaction you can increase the strength of your soil, and if the strength of soil will be increased, then it can bear the load of the structure. Compaction also decrease the amount of undesirable settlement of structure and increase the stability of slope embankment. Now you can see here what is the meaning of compaction. There are some images which is showing how to affect it on the structure. First, you can see there is poor compaction. If there will be poor compaction, if any vehicle will move on the road, then it will impart a impression on the road. And if your soil will be good compacted, as you can see here, there will be no impression of the tire of the vehicle. And poor compaction, high resistance to deformation, high resistance frost damage, as you can see here. And poor compaction, this is suppose a structure of foundation, and you can see the settlement of structure in the poor compacted soil and in the good compacted soil. Now we will see the purpose of compacting of soil. It increases the shear strength. This means larger load can be applied to the compacted soil since they are typically stronger, increased shear strength, increased bearing capacity, slope stability, and pavement system strength. Reduce permeability. It also reduces the permeability when you will. And first things was very important, increase shear strength, because if your soil will be not well compacted, what will happen? There may be a chances of shear failure. And you can see here second point which is given here, reduce permeability, and this inhibits soil ability to absorb water and therefore reduce the tendency to expand, shrink, and potentially liquefy. And here you can see reduced compressibility. This is also mean that larger load can be applied to the compacted soil since they will produce a smaller settlement. Fourth point is here, control swelling and shrinkage. If you will do proper compaction of your soil, it will control the swelling and shrinkage of the soil. It will also reduce the liquefaction potential of the soil. Now we will see the compaction of soil again. What might be the different uh, definition of the compaction? Compaction in general is the densification of soil by the removal of air, which require mechanical energy. Simplistically, compaction may be defined as the process in which soil particles are forced closer together with the result reduction in the air voids. In general, you can say compaction is the method of removing air voids from the soil. What is the principle of compaction? This is also a very important point here. As you can see, compaction of soil is achieved by the reducing the volume of voids, and it is assumed that compaction process does not decrease the volume of the soil grains. As you can see, soil before the compacted and what is happening in the compacted soil means here you can see the voids is removed by the compaction, and soil before the compacted and soil after the compacted, you can see here the soil particle is closer to each other. Here soil particle is not closer to each other, and they will not bear the high load. And if soil particle will be near to each other, it can bear a lot of load of your structure. Now, how it can be effect, as you can see, this is your three-phase diagram. And in loose soil, you can see here there is air and water. And their quantity of air is more in the loose soil. If you will see the diagram of compacted soil, then you can see there is less amount of water is available in the fully compacted soil. There is also principle of compaction, which is saying the degree of compaction of soil measured by the dry unit weight of the dry unit weight correlate with the degree of packing of the soil grain, which will be equal to gamma d equals to gamma wgs plus 1 plus e, where you can see this is bulk density, this is your specific gravity, this is your Y to ratio. The more compacted soil is, the smaller its void E will be. The higher its dry unit weight, gamma del V will be. Means if your soil will be full compacted, then air void will be less and dry unit weight will be higher. Now we will see the compaction curve. The compaction curve is the relationship between a soil water content and dry unit weight. Soil sample was computed at different level, as you can see here, and the formula will become gamma will be gamma upon 1 plus wc. Compacted curve is plotted between the water content and dry density. Soil type, again we will see the soil type, how it can affect the compaction of a soil. In poorly graded sand, the dry unit weight initially decrease as the moisture content increase and then increase to the maximum value with the further increase in the moisture content. At lower moisture content, the capillary tension inhibited the tendency of soil particle to move around the compacted. And this is also one factor which is given here, how soil type can affect the compaction. At the given moisture content, a clay with low plasticity will be weaker than the heavy or high plastic clay. So it will be easier to compact. So you can understand here how soil type can affect the compaction. Now you can see this graph, and this is also showing the soil type, which is affecting on the compaction, as you can see. Now, effect of compaction efforts. What kind of efforts you have to use for the proper compaction? As you can see, the compaction energy per unit volume used for the standard Proctor test can be given as E will be equal to number of blows per layer into number of layer into weight of the hammer into height of drop upon volume of the mold. Soil type, again we will see the soil type, how it can affect the compaction of a soil. In poorly graded sand, the dry unit weight initially decrease as the moisture content increase and then increase to the maximum value with the further increase in the moisture content. At lower moisture content, the capillary tension inhibited the tendency of soil particle to move around the compacted. And this is also one factor which is given here, how soil type can affect the compaction. At the given moisture content, a clay with low plasticity will be weaker than the heavy or high plastic clay. So it will be easier to compact. So you can understand here how soil type can affect the compaction. Now you can see this graph, and this is also showing the soil type, which is affecting on the compaction, as you can see. Now, effect of compaction efforts. What kind of efforts you have to use for the proper compaction? As you can see, the compaction energy per unit volume used for the standard Proctor test can be given as E will be equal to number of blows per layer into number of layer into weight of the hammer into height of drop upon volume of the mold. As you can see here, that is your compaction curve, which is showing the value of compaction of a soil. It is observed that the dry density increased with an increase in the water content till the maximum density is attained. With further increase in the water content, the dry density decrease. As you can see here, On one point, we are getting the maximum dry density, which is also known as MMD, maximum dry density, which we get on the OMC, means maximum water content. Maximum water content. Now, optimum moisture content OMC is also given here, as I told you earlier. The water content corresponding to maximum dry unit weight is called optimum moisture content. Note, the maximum dry unit weight is only maximum for the specific compactive effort and method of compaction. As you can see here, that is your optimum moisture content, and that is your gamma D maximum, means you are achieving here the maximum dry density of soil. Soil type, again we will see the soil type, how it can affect the compaction of a soil. In poorly graded sand, the dry unit weight initially decrease as the moisture content increase and then increase to the maximum value with the further increase in the moisture content. At lower moisture content, the capillary tension inhibited the tendency of soil particle to move around the compacted. And this is also one factor which is given here, how soil type can affect the compaction. At the given moisture content, a clay with low plasticity will be weaker than the heavy or high plastic clay, so it will be easier to compact. So you can understand here how soil type can affect the compaction. Now you can see this graph, and this is also showing the soil type, which is affecting on the compaction, as you can see. Now, effect of compaction efforts. What kind of efforts you have to use for the proper compaction? As you can see, the compaction energy per unit volume used for the standard Proctor test can be given as E will be equal to number of blows per layer into number of layer into weight of the hammer into height of drop upon volume of the mold. Effect of increasing competitive efforts. Increased competitive efforts enable greater dry unit weight. It can be seen from the figure that is compaction curve is not unique soil characteristics. It depends on the compaction energy. As you can see here, that is your high competitive efforts curve, and this is your low competitive efforts curve, and that will be your OMC1 and that will be OMC2. In here, you can get easily, you can get you will get your maximum dry density on 14, and here you can see you are getting optimum moisture content, maximum dry density till the 12.4. Now, effect of increasing competitive efforts. For this reason, it is important when giving value of maximum and OMC is also specify the compaction procedure. From the preceding observation, we can see that as the compaction efforts is increased, the maximum dry density unit weight of compaction is also increased. As the compaction efforts is increased, the optimum moisture content decrease to some extent. Now we will see what is the method of doing the compaction, and it may be different for the coarse grained soil and it may be also different for the fine grained soil. As you can see this table, and there is also two method is given. First one is a laboratory method and second one is a field method. As you can see there, if coarse soil grain will be, we can use the vibrating hammer. If fine grain soil will be here, falling weight and hammers and static loading and press we can use. And these are the different method of compaction which is used for the different soil. If soil will be coarse grained soil, this method will be used, as you can see. And if your soil will be fine grained, this method will be used for the compaction. Now we will see the laboratory compaction test. Laboratory compaction test provides the basic for determination the percentage of compaction and molding water content needed to achieve the required engineering properties, and for controlling construction to assume that required compaction and water content are achieved. The aim of the test to stabilize the maximum dry unit weight that may be attained for the given soil with the standard amount of competitive efforts. When a series of samples of soil are compacted at the different water content, the plot usually shows a distinct peak. The fundamental of compaction of fine-grained soil relative new, which we know as the Proctor test, which is developed in the 1930s for the principle of compaction. The Proctor test is impact for the compaction. A hammer is dropped several times on the soil sample. In a mold, the mass of hammer and height drop, number of drops, number of layer of soil, and volume of the mold are specified. As mentioned here, the Proctor test is used for the getting the maximum dry density of soil. In Proctor test, you have to fill the soil in the three layer, as you will see in the uh, next slide. And we have to put the hammer on it, and it depend on the number of blows, how much number of blows you are putting on the soil, and it will also depend on the your soil quality and soil types. So we can see here there are several types of tests which can be used in the study of competitive properties of soil. First one is there is two method for determining the maximum dry density, which is also known as the compaction test. First one is the standard Proctor test, which is not sufficient for the airways and highway. And second one is modified Proctor test was later adopted by the ASTO and ASTM. Proctor stabilized that compaction is the function of four variables. First one is dry unit weight or dry density and dry unit weight. Second one is water content, which is known as WC, and competitive efforts energy, which is uh, shown by the E. And soil type, in soil type, it will depend on gradation, presence of clay minerals, etc. The soil is mixed with varying amount of water achieve the different water content. Several samples of the same soil but at different water content are compacted according to the compaction test specification. Apply 25 blows from the ram drop from the height of 305 above the soil. As you can see here, we have to put our soil in the three layer, and this is your hammer, and it should be dropped from the 300 height. Now you can see here the first four blows and successive blows. Distributed the blows uniformly over the surface and ensure the rammer always fall freely and not obstructed. As you can see, first you have to put like this: one, two, three, four. After that, you have to repeat like 4, 5, 6, 7, 8, 9, 10. Then you have to go around this. Means you have to drop your hammer in this manner. The soil is mold will be divided into three lifts. Each lift is compacted 25 times. Place a second quantity of moist soil in the mold such that when compacted it occupies a little over two-thirds of the height of mold body. As you can see here, this is your height and this is your uh, weight of hammer, and this is your layer number of layer, which is equally divided into each part, and you have to put 25 blows per layer on this sample. Repeat procedure once more, and then once more, so that amount of soil be used sufficient to fill the mold body with the surface not more than 6 prod of upper edge of the mold body. Soil type, again we will see the soil type, how it can affect the compaction of a soil. In poorly graded sand, the dry unit weight initially decrease as the moisture content increase and then increase to the maximum value with the further increase in the moisture content. At lower moisture content, the capillary tension inhibited the tendency of soil particle to move around the compacted. And this is also one factor which is given here, how soil type can affect the compaction. At the given moisture content, a clay with low plasticity will be weaker than the heavy or high plastic clay. So it will be easier to compact. So you can understand here how soil type can affect the compaction. Now you can see this graph, and this is also showing the soil type, which is affecting on the compaction, as you can see. Now, effect of compaction efforts. What kind of efforts you have to use for the proper compaction? As you can see, the compaction energy per unit volume used for the standard Proctor test can be given as E will be equal to number of blows per layer into number of layer into weight of the hammer into height of drop upon volume of the mold. The unit weight and actual water content of each compacted sample are measured, derived and dry unit weight from the known unit weight and water content, which will be equal to gamma uh, 1 plus WC. And this is the formula which we have to use during the compaction test. And these formulas very important, which you have to remember always for doing this test. Without this formula, without the help of this formula, you cannot even perform this test. That's why you need to remember this formula. Okay, now you can see this is your graph which you have to plot by the doing the test, and you have to also determine the dry unit weight, which is known as which you will get on the OMC. Okay, that formula is showing how you can get the water content of a soil. Now come on the table how you have to calculate this uh, how you have to calculate the uh, standard Proctor test procedure and results. And there is a diameter of mold which is given here, volume of mold, volume of hammer, height of hammer drop, number of hammer blows, and the layer of soil. And these things you have to you have to remember always for doing this test. Okay, and now you can see these are the method which you have to adopt during the compaction. And there is also some different value which you can get on the different mixing proportion. Come on the here specification of standard Proctor test, which is based on ASTM test and designated by the 698 soil to be used. And these are the three method which we use for the determination of Proctor test. And by this method, you can determine the compaction value of soil. Now we will see the modified Proctor test. It was developed during the World War II, and it was also developed by the US Army Corps of Engineers for better representation of the compaction required for airfield to support heavy aircraft, as you can see here. And you can see the same as the standard Proctor test with the following exceptions. The soil is compacted into 5 layers. Hammer weight is 100 lbs, which will be equal to 4.5 kg. Drop of height h is 18 inch or 45.72 centimeter, and then the amount of energy is calculated. Uniformly distributed of blows surface. As you can see here, there is Ramer pattern for the compaction which you need to perform during this test. And this is the table, how you have to plot the table. As you can see, first one is the diameter of mold and volume of mold, weight of hammer, height of hammer drop, number of hammer blows as per layer, number of layer, compaction, energy of compaction. So you can see here, you have to do the compaction of three sample, and after three sample, you can determine the average of the modified Proctor test, which will give the optimum moisture content. On that content, you will get the maximum dry density of a soil. So, a specification of a standard Proctor test, which is based on ASTM test, which is designated by 698. And there is a soil method A, B, and C. In A method, portion of passing number 457 mmC may be used, and here is given 9.5 mmC, and here is given 90 mmC. So you can understand these are the three methods where we are using different kind of sieve for the compaction. Now this is the compaction curve, and that is also, you can say, this is comparison curve between the dry density which we got by the standard Proctor test, and second one is showing which we got the dry density by the modified Proctor test, as you can see here. Now we will also do the comparison of summary, and in standard Proctor test, mold size will be equal to 943.3 centimeter cube, and here the mold size will be the same. The height of drop is different here, which is in standard Proctor, which is 304.8 mm height, and here you can see it is equal to 457.2 mm height of drop. Here you can see 25.4 number below hammer, and here is also 24.5 n hammer. There will be three layer in standard Proctor test, and here will be five layer in the modified Proctor test. And there you have to use the 25 blows per layer. Here also you have to use the same number of blows in the compaction of the soil. Now we will see the energy, and which will be used here. More energy are using in the modified Proctor test. Now we will see the field compaction, how you will do the field compaction of a soil, and that compaction was can be done in the laboratory, but this compaction will be on the real field, and this method is also very important, which you have to use during the construction of structure. There are compaction equipment. Most of the compaction in the field is done with the roller. The four most common types of roller are: first one is the smooth wheel roller, a pneumatic rubber tire roller, seafood roller, and vibrating roller. These roller can compact the soil very well, and they can also increase the uh, bearing capacity of soil. Now we will see the first. Smooth wheel roller are suitable for the proof rolling and subgrade and for finishing operation of field with the sandy and clay soil. These rollers provide 100% coverage under the wheel with the ground contact pressure as high 310 and 380 Newton per meter square. They are not suitable for producing high unit weight of the compaction when used on the thicker layer. As you can see here, that is a smooth wheel roller. This is an image of a smooth wheel roller, and one steel drum and rubber tire drive wheel. Two steel drum, one which will be driver and effective for the gravel, sand, and silty soil. These will be effective for the gravel and silt soil. Now we will see the Pentamic rubber tire roller, and this is the better in many respect of the all roller. The former heavily loaded with the several rows of tires. These tires are closely spaced 4 to 6 in a row, and compaction is achieved by the combination of the pressure and kneading action. Now you can see that is a pneumatic rubber tire roller which is very effective in the field. Next we will see the seafood roller which we use in the field. Seafood roller are drums with the large number of projection. The area of each projection may be ranged from the 25 to 85 centimeter square. These rollers are most effective in the compacting clay soil, and the contact pressure under the projection can be ranged from the 1400 to 7000 kilonewton per meter square. And during the compaction in the field, the initial passes compacted the lower portion of leaf. Compaction at the top of the middle of the leaf can be done later stage. As you can see here, this is your seafood roller, which is also very effective on the field, which can easily compact soil very well. And this is also image of seafood roller. And next is vibratory roller, which is are extremely efficient in the compacting granular soil, and vibrator can be attached to the smooth wheel. Pandemic rubber tire are seafood roller to provide vibratory effect on the soil. The vibration is produced by the rotating of the center of weight. And now you will see the factor affecting the field compaction. For field compaction, soil is sprayed into the layer for predetermined amount of water sprayed on the each layer of soil, after which compaction is initiated by the desired low roller. In addition to soil type, moisture content, and other factor must be considered to achieve the desired unit weight of the compaction in the field. These factors include the thickness of lift and intensity of pressure applied by the compaction equipment and the area over which pressure is applied. These factors are important because the pressure applied on the surface decrease in the depth, which result in the decrease in the degree of soil compaction. During the compaction, the dry unit weight of soil also affected by the number of roller passes. The dry unit weight of soil at given moisture content increase to the certain point with the number of roller passes. Now we will see the specification for the field compaction. In the most specification, the earthwork, the contractor is instructed to achieve the compacted field dry unit weight of 90 to 95. The maximum dry unit weight determined by the laboratory by the either standard modified test. And this is the specification for relative compaction, which can expressed as R will be gamma D field upon gamma D maximum, which we are getting in the lab into 100%, where R will be the relative compaction. For the compaction granular soil specification, sometimes written as the relative density dr, or required to relative compaction. And relative densities should be not confused. The relative compaction, both are the different. Now, when compaction work is in progress, knowing the whether specified unit weight has been achieved is useful. The standard procedure for determining the field unit weight of the compaction include sand cone method, rubber balloon method, and nuclear method. These are the method of determination of field unit weight by the compaction. First one is sand cone method, and sand cone method is designed and designated by the ASTM D1556. And the sand cone device consists a glass of plastic jar with the metal cone attached at its top. Determine the field unit weight of compaction. You can see there is also one nuclear method which is very special and which is also used for the determination of unit weight of the soil or compaction. Now we will see the MCQ, and these MCQs are very important. And as we saw, what is the role of compaction and how it can be effect on the soil. First question is given, what shows the existence of relationship between soil water content and degree of dry density in 1933? First option is given, Tarjagahi, Darcy, Proctor, and none of these. And this is also a very important question, and there will be right answer will be D. Who developed the standard proctor test? This is also very important. Many exams, this types of question come. Option is given R.R. Proctor, Darcy Tarjaveh, none of this. Then here right answer will be A. R.R. Proctor developed the standard proctor test by which we determine the dry density of a soil by the achieving the maximum water content, which is known as optimum moisture content also. How many inches the inside diameter of mold is in the Proctor testing? Option is given here: 1, 4, 3, 6, and none of these. Here right answer will be your uh, B, which is your 4. How many inches the inside diameter of mold? If these types of question will come, then you can answer it. It will be 4. What is the capacity of mold in the standard Proctor test? As you can see, 1 by 10 cubic feet, 1 by 20 cubic feet, and 1 by 30 cubic feet, 1 by 40 cubic feet, none of these. Here right answer will be your C, which is 130 cubic feet. What is the weight of primer in the standard Proctor testing, which is equal to 4.5 kg, 18 lb, 2.5 kg, 20 lb, and none of these. Here right answer will be your uh, C, which is equal to 2.5 kg. Now come on the next question. What is the free fall height in the standard Proctor test? And it is 5 inch, 12 inch, 6 inch, 16 inch, and 18 inch. It will be equal to 12 inch, means the free fall height of the standard Proctor testing is 12 inch. What is the internal effective height in the standard Proctor testing, which is given here: 2.3 inches, 4.5 inches, 4.6 inches, 45 inches, and none of these. Here right answer will be C, which will be equal to 4.6 inches. The compaction increase the void ratio, true, false, and partially true. What will be the right answer? Right answer will be B. It is false. It decreases the void ratio. It cannot increase the void ratios. That's why we get the good strength by the decreasing the void ratio. What is reduced by the compaction? Strength, stability, air voids, dry density, none of these. Here right answer will be C. It can compaction reduce the air voids from the soil sample. What are the process called in which soil particle artificially rearrange into the closed stage? Tension, compaction, swim, mechanism, consolidation. None of these. Here right answer will be here B, which will be compaction. And now come on the reference. This is your reference link, and this is also your geotechnical book, which is written by the T.N. Ramamurthy and T.G. Sitaram. This is the very important book, and by this book you can understand very well what is the compaction of soil. Compaction of soil is generally we do, and today we saw the how to do compaction and what is the method of doing the compaction. Like we saw standard Proctor test, uh, we also saw uh, modified Proctor test, and these tests are very important in the geotechnical engineering, and these tests you can even perform in your lab. In our lab, these tests are available by the standard Proctor test and modified Proctor test. In field test, you can see on the road projects where a lot of roller used for the making the roads. What they do, they compact the soil very well by the putting the water on it. And before that, they have to determine what is the maximum water content and what is the optimum moisture content for that soil, and they put water on that basis. They cannot put water freely. They have to first determine the optimum moisture content, on which optimum moisture content soil is being hardened, means what is the maximum dry density of soil. After that, they have to put on water and they have to roll it properly, and that's why we got the very proper compaction and strength, as which can resist the load of structure. This was the all about the compaction, and thank you for watching this video.